Welcome to this YSL tutorial. In this video, we're going to talk about how you can write Excel VBA code to query a database using ActiveX data objects. We'll start the video by talking about how you can set a reference to the ADO or ActiveX data objects library, and then how you can use this to create a new connection object. We'll spend a bit of time discussing how to set the connection string for your connection and show you several different methods for how you can do that, and we'll create connections to both a Microsoft Access database and a Microsoft SQL Server database. Once we've created the connection, we'll talk about how you can create a new record set, load records into the record set, and then copy that data into an Excel worksheet. Towards the end of the video then, we'll start talking about how you can write SQL queries in VBA. So this links in quite nicely with the video series we've made on exactly how to do this. Right at the end of the video, we'll show you how you can then ask your users to provide inputs which modify the results of the queries, so essentially designing your own little query tool using Excel VBA. So there's quite a lot to do and quite a few technical ideas involved. Let's get started. For the first example in this video, we're going to write a routine which connects to a database, loads a table of data into memory, and then simply copies that data into a new worksheet in our workbook. We'll demonstrate this for both a Microsoft Access database and then for a Microsoft SQL Server database as well, mainly just to show you how simple it is to get ADO to talk to essentially any kind of database. For this video, I'm going to be using Excel 2013, but it doesn't really matter which version of Excel you're working in. We'll write the code so that it will work with any version essentially. So to get started, let's head into the VB editor. And I've already made a start by creating a module for myself. In there, I'm going to create a new subroutine called copy data from database, and then we can start writing some code that will do exactly that. The easiest way to write code using ADO involves setting a reference to the correct object library before you start writing any code. So let's head to the Tools menu and choose References. And then we can scroll through the huge list of available references to the section that has Microsoft ActiveX data objects listed. Sounds very exciting, doesn't it? It's not that exciting, to be fair. These are the ADO object libraries, and you'll always have a number of different libraries installed, depending on which version of Windows you're working in. If you're interested in the history of these versions, and let's face it, who isn't interested in the history of ADO, a quick Google search will turn up this help page for you, so you can get an idea of why each version exists. And this page is a little bit out of date. It only lists up to version 6.0, which was released in Windows Vista, and the versions prior to that were from Windows XP and earlier. So obviously it makes sense to go with the latest version we have available. So if I just head back to my VB editor, 6.1 was released in Windows 7, I believe, so that's the version that I'm going to use for now. A little bit later on we'll make sure we can edit the code so that it will allow us to talk to any version of ADO, regardless of which version is installed on the user's computer. But for now, let's go with the latest version we have available. So in my case, that's the 6.1 library. Yours might be different. But click OK when you've done that, and that gives us access to a whole range of extra objects and collections and methods and properties. If you want to see what they are, you can head to the View menu and choose Object Browser. And in there, if you use the drop-down list at the top of the window to choose the ADODB library, this is the one that you've just referenced, this will give you an idea of all of the new types of classes and constants and all sorts of other things that you've made available to your VBA project. So close down the Object Browser, and what that lets us do now is create a variable which can hold a connection object. Declaring a variable to hold a connection object is fairly straightforward. Let's start with dim. I'm going to call my connection moviescon because we're going to be connecting to a movies database as, and what I want to store or set a reference to is a type of object called a connection, which I can just reference by stating literally the word connection, but I always think it makes sense when you're referencing classes from a different object library to precede the name of the class with the name of the library to which that class belongs. So I'm going to say ADODB, you'll see the little icon for a library there, a little set of books, followed by a full stop, and then you can look for the connection object there. Okay, so that's the variable that will hold the reference to the connection. What we need to do next is create the new instance of the connection. We can create the new instance of a connection by simply saying set moviescon. I've pressed Control and space there, by the way, on the keyboard to display this IntelliSense list. Set moviescon equals new ADODB dot connection. And once that's been done, we've got full access to all the methods and properties of our connection by simply referencing our variable, moviescon. If you type in a full stop, you can see the full list of all the things you can do and all the properties you can change on that connection object. The most important property to start with is the connection string property, so let's have a look at how to modify that next. Actually, before we start looking at how to set the connection string, I wanted to mention a couple of other methods you could use to create the new instance of the connection. So I'm going to make a quick copy of this subroutine and paste it in down below. And I'm going to change the name of this so that it's called Copy Data from Database Auto Instancing. You may have heard us mention this in previous videos. The idea is that rather than explicitly setting the movies connection object to be a new instance when you want it to be created, you can actually incorporate the new keyword into the variable declaration. So you can say dim moviescon as new adodb.connection. Now, somewhat misleadingly, that declaration doesn't actually create the new instance of the connection. What happens is that the VB editor will wait until you first reference the variable, moviescon, and whenever you reference that variable, the editor checks to see if it references an object or not. If it doesn't already reference an object, then the VB editor will automatically create a new instance for you, which sounds brilliant and really convenient. It saves you an entire line of code. There are a couple of small downsides to it though. First of all, it's not just the first time that the variable is referenced, it's every single time you reference this variable in this subroutine that the VB editor checks to see if it references an object or not. So it adds a small overhead to your procedures when you're using auto-instancing variables. On top of that, it means that you can't write your own explicit tests to say things like if moviecon or moviescon is nothing, then you might want to, I don't know, display a message that says the connection doesn't exist. But with this type of variable, with an auto-instancing variable, this test will never ever work. As soon as we attempt to run it, I'm going to use the F8 key to begin stepping through. As soon as we begin to run it, you can see at this point that the moviescon is not set. That's what the little message tells us. But as soon as I press F8, the auto-instancing variable automatically creates an instance of it, so this means that we can never check if it's nothing. So you can see it's now actually created an instance of an object. So a couple of very small downsides to using auto-instancing variables, which means I don't tend to use them myself in the real world. I tend to use the explicit setting of the new instance like we've done in the first example here. One other way to create a new instance of a connection object is to use a VBA function called createObject. So what I'm going to do is I'm going to remove this subroutine that I just used to demonstrate auto-instancing variables, and instead I'm going to copy and paste this original subroutine one more time. I'm going to change its name so I have the words using createObject to the end, so it's got a unique name. And then what I'm going to do is change the word new to a call to the createObject function. If I open a set of round brackets after that name, you'll see it's got two parameters. The first compulsory parameter is called class as string. So essentially this is the name of the class of object that I'm trying to create, but passed in as a string of text rather than a direct reference to that class of object. So this code here will do essentially exactly the same job as this code here. So what is the point, you may ask? Well, the point of using createObject is to handle the situation where you're perhaps passing this code to somebody else who has a different version of the ADODB object library installed on their computer. If you remember earlier, I headed to the Tools menu and chose References, and we checked a reference to this specific version of the ADO object library. Well, what happens if you send this code to somebody who does not have that version installed? That means that this code will not work. So what I'm going to do at this point is I'm just going to uncheck that reference and click OK. That means that at this point, neither of these two subroutines will work. As soon as I attempt to run it, I'll get a compile error saying that it doesn't understand what this type of thing is, an adodb.connection. Now that will be true in this case. If I just reset this subroutine, that's still true for this example at this point as well, because I'm trying to reference directly an adodb.connection. So instead what I'm going to do is remove that keyword and replace it with the more generic object. So what I can find now is if I attempt to run this subroutine using the F8 key to step through, we'll find that this will work absolutely perfectly. So the idea behind using createObject is to make your code essentially version independent. You could send this subroutine now to anybody else with any other version of Ado, and that would allow them to run the code. One big huge downside to using this createObject function, this technique is called late binding, by the way. So late binding is when you don't set a reference to an object library. You can probably guess what the other type of binding is called. That's right, early binding. There you go. So that's when you do set a reference to the object library. The big downside to late binding is that, as you saw earlier on, we got the IntelliSense list to show us all the things we can do to our connection. In this case, with late binding, you don't get any help whatsoever. So for that reason, for the rest of the video, I'm going to be using early binding techniques while we write the code, and a bit later on I'll talk about how you can convert the early bound version of your subroutine into a late bound version of the subroutine so that it will work for other people. So I'm just going to remove that copy of the subroutine altogether for now, and I'm going to go back to the Tools menu and choose References, recheck the reference to the Microsoft ActiveX Data Objects 6.1 library. There it is, check the box, click OK, and now all the code will work again. I'll just remove that quick comment there as well. Okay, so having talked about the various ways to create the new instance of the connection, we now need to set the connection string property. Now the connection string tells the connection essentially what kind of database to connect to, where that database is stored, any security parameters such as passwords and so on and so on. So it can be quite a long, complex string of text. You certainly don't want to be typing these things out yourself. So where should one go for all one's connection string needs? Why, connectionstrings.com, of course. A quick Google search for connection strings will return this website as the top hit every single time. So if I just quickly head to this site, it is the single most humorless website on the whole of the internet. I'll just warn you of that now. Oh, except for the name actually, which is written out as a string, which I think is quite cute. There's a bunch of articles that explain a little bit more about how connection strings work, but I think I know about as much as I ever want to know about connection strings for the time being. All you really need to do to find your connection string syntax is to look in the list on the right hand side, and this is a list of all the various different types of databases you can create a connection string to talk to. And these are designed purely to work with the Ado object libraries. So if you can't find your database type on there, then I'm afraid you're a little bit out of luck, but we can certainly find the connection for our Access database. And that's what we're going to try to connect to first, an Access database created in Access 2007. So if I click the Access link, what I'll be taken to then is a page full of all sorts of different examples of Access connection strings. Now there are many, many, many different types using various different parameters and for various different situations you might find yourself in with your databases. There are a few descriptions about what each one is, and there are quick links as well to take you to specific versions for Access as well. Now the type of database we're going to connect to, if I can just quickly show you this, I'm showing you this in Access 2013, although I originally created the database in Access 2007. I'll make this available for download as well. I'll put a link in the description at the bottom of the video, just in case you wanted to download this to practice for yourself. So you can see that it's in an Access 2007 to 2013 file format with an ACCDB extension. So heading back to connectionstrings.com, essentially, all I need to do is copy this original standard basic copy of the connection string. I don't have a password on the database, although if I did want to put a password in, you can see there's another example here that allows me to set a password. Now obviously there will be certain parts of the connection string that I'll need to change to make it specific to my particular database, such as where it's stored, but for now all I'm going to do is take that string, select it, copy it, and then head back to my VB code and paste it into that set of double quotes just after moviescon.connectionstring equals. Let's just tidy up a little bit as well, as I've copied it across two separate lines. I need to make sure that it's all in one single continuous string. I suppose I could concatenate it out of various different parts, couldn't I, to make it fit on a single screen width. I'm actually going to use the continuation character here just to bring this down to the next line to make it a little bit easier to read. Can I squeeze it all into one single line? Not quite. I think just for the time being I'm going to leave it as this. I'll just scroll across a little bit so you can see the full string. But there we go, there's our basic connection string in our VB code. What we need to do next is change it so that it will point to our specific Access database. Okay, so I've stored my Access database in a folder on my desktop called Databases, conveniently, and that's the path to the database. So I'm going to just copy that path from a Windows Explorer window just for the sake of convenience for the time being, and then back to my VB code, and I'm going to replace this part of the string, the connection string, with the thing that I've just copied from the Windows Explorer window. Now I also need to reference the name of the database here as well. So after the folder name databases, I can type in a backslash, and then the name of the database was called movies.accdb, and that will generate the correct connection string to connect to my database. This is hopefully obviously the biggest part that can go wrong when you're using Ado, the connection string, getting the connection string wrong. So what I'd like to do just now is to test whether or not my connection string is working properly. And to do that, I'm just going to simply try to open the connection and then immediately close it back down again. So to do that, I can now say moviescon, I'll try that again, moviescon.open, it's nice and simple, and then moviescon.close. It's always important to close down your connections once you finish with them. So having done all that, let me just give this quick subroutine a quick run, and as long as nothing goes wrong, as long as I don't get any error messages, if I just step through that to prove that it is actually doing something, as long as you don't get any error messages, that's an incredibly good sign. So that means that our connection string is successfully pointing to a valid database. Now that we've connected to one database type, I want to show you how simple it is to change Ado to essentially connect to any type of database. So I've also got a copy of the movies database as a SQL Server database, and this is roughly what it looks like. There it is, movies, sitting on a specific instance of SQL Server on this laptop. So what I am going to do is write a connection string, or more accurately, copy a connection string that will connect to this specific movies database. So I'm going to return back to connectionstrings.com. This will become your best friend, this website. You'll have this bookmarked almost instantly, I think, after watching this video. We'll have a scroll down the list to find the SQL Server connection strings, and I'll click on that option. Now, there are a lot more types for SQL Server, an enormous list actually compared to the Access list, and finding the specific one to you means you need to know a little bit about SQL Server itself. I've got a specific instance of SQL Server created, so what I'm going to do is I'm going to scroll down the list. The top of the list basically talks about the .NET SQL Server connection strings, and I'm not connecting to a .NET or not programming in .NET. So I'm going to scroll down the list a little bit further to find the SQL Server Native Client section. Okay, so there's a couple of basic examples again, just like there was for Access, and there's also one here that talks about how to connect to a specific instance of SQL Server. So what I'm going to do here is copy this string again, just like I did for Access. And again, there will be a couple of small things that I'll need to change, so specifically the server name and the instance name, and also the database name. If I go back to my VB editor though, having copied that string, I'm just going to comment out these two lines first of all, and replace these two lines with a reference to set the movies con again, connection string equals, and I'll have another space underscore to continue writing this on the next line. Then I'm going to open and close in double quotes, paste that connection string in, oops, and I also need to make sure that that's all fits onto one single line. Okay, so the provider is this. The provider that I copied there was for SQL Server 2012, which is the instance that I'm connecting to, or the version of SQL Server that I'm connecting to. Again, there are different links for different versions of SQL Server, which you can see at the top of the connection strings page. All I need to do though is I need to change the name of the server and the name of the instance and the name of the database. So again, just having a quick look back at my SQL Server Management Studio, the name of the server is the name of the laptop there, inventively called Dell Vostro 2. You can probably work out what kind of laptop I'm using to do this. And then a backslash, and then the name of the instance, SQL 2012. So can I copy? I don't think I can copy that text from there. No, I can't. So what I'm going to do is just have to write that out. So I'm going to write out Dell Vostro 2 backslash SQL 2012. So let's do that. This is the server name, essentially, and the instance name is SQL 2012. The database name, as we saw, just quickly looking back at Management Studio, is the name movies again. So back in the VB editor, replace the word my database with the name movies. Okay, so once again, we want to quickly test this. I'm going to use the F8 key to step through. So we'll set the connection string to the SQL Server connection string now. And then, if I try to open the connection, it should successfully open, as long as it doesn't fail. As long as I don't get any error messages, that means that the connection's worked. And I'll make sure to close the connection down again as well by pressing F8 again. So that genuinely is how simple it is to make Ado talk to any type of database. A bit later on in the video, when we're talking about writing SQL instructions, so actually writing out our own queries in VBA, there may well be a few other tweaks that we'll need to make specific to the syntax of SQL that's being used for your specific kind of database. But other than that, Ado is just beautifully generic. So now that we've got a way to connect to different databases, we should probably move on and start talking about how to actually get some data. Just before we move on, I want to mention one technique you can use if you're having trouble building a connection string using connectionstrings.com. What you can do instead of trying to construct it yourself is actually get Excel to build a valid connection string for you using one of its wizards. If I head back into Excel and head onto the Data tab of the ribbon, there's a tool that lets me get external data, and if I click on this tool, there are various options in here for importing data from various types of databases. So of course there's an Access option, and then there's also an option for SQL Server, and various other things as well. If I click on the Access option for now, this will launch a wizard letting me import data from the Access database. So let me head back to my desktop and find the databases folder and choose the movies database. So if I select a table just for the sake of progressing through the wizard and click OK. On this stage of the wizard, I've got a button here that allows me to view the properties of the connection that I'm creating. If I click the Properties button, there's a Definition tab on the Connection Properties dialog, and that shows me a complete connection string to successfully connect to that database. Now, it will be enormous compared to the simple connection strings we've generated using connectionstrings.com, but all we need to do here is copy the entire string from the dialog box, and then close the wizard down. I'm going to cancel out of both dialogs, switch back to the VB editor, and then I'm going to comment out the lines that connect to SQL Server and have another line which sets the connection string for our movies.com. So movies.com dot connection string equals, and let's put this on another line. There's no way I'm going to get the whole thing onto one single screen width because it's so long, but I'll just paste in the entire string into that set of double quotes. So there it is. Now technically, because we've copied this from a dialog box and we know that this will work to connect to our movies database, technically this should just work, but unfortunately, if I try to run the subroutine, I'm using F8 to step through, we'll find that when we get to the point where we open the connection, it fails. Now the reason for that is because of exactly what text we've copied out of the connection string dialog box. If I just end the subroutine, the problem is all down to the fact that this connection string incorporates double quotes. And in VBA, when you want to incorporate a set of double quotes inside a string, so inside a larger set of double quotes, then if you put two double quotes in a row, that only generates a single double quote in the final string, which is a bit annoying. The solution to making this work is to actually double up your double quotes. So essentially put 4 sets of double quotes in a row, and that will put in 2 double quotes in the final string. Now the problem is there's loads of different examples of that in this entire connection string, so I'm going to have to go through the entire thing by hand essentially and find every single instance of a double quote and make them into 4 double quotes instead, which gets a bit tedious admittedly, but it's important to do, otherwise the connection string simply won't work. So let's keep going through. Sorry, this bit's a bit boring, apologies for that. There's another one. I want to make sure that I get them all, otherwise the whole thing will just fail. I think that's looking pretty much like we're there. Yep, there we go, there's the end of the string. Okay, so having replaced all the double quotes with quadruple double quotes, we can step through the subroutine again using the F8 key, and this time the connection opens successfully and it works. If you want to use the same technique to generate a connection string for a SQL Server database, then the wizard is slightly different. If I switch back into Excel and head back to the Data tab, choose Get External Data, this time I'm going to go for From Other Sources, and then choose From SQL Server. Now the first step of the wizard, I'd have to type in the name of the server, and in this case my instance name as well. So if you remember my inventively named server, delvostro2 \SQL 2012, which is the name of the instance, then I can click Next. Then I can choose which database on that instance or that server I want to use. I'm going to choose movies. And again, I'm going to choose the actor table to begin with. Then click Next. Now this stage actually asks me to save the data connection file. So I'm going to give my connection file a sensible name at this point. So I'm going to call it Movie Connection. Sounds sensible. And then I can click Finish to save that file. This gets me back then to the same place I was with the connection for Microsoft Access. If I click the Properties button and then choose Definition, this will give me access to the connection string again. So again, I can copy this and then head back to, cancel out the dialog box first and cancel out the next one, back to the VB editor, and again, I could replace this connection string. Let me just delete that one that I just invented there. And inside another set of double quotes, paste in the connection string for SQL Server. Now I think we're a bit lucky in this case in that this connection string doesn't include any double quote characters. So as I scroll back through the page, it's a much shorter connection string as well than the one for Access. So with this one, we don't have to make any modifications at all. If I just use the F8 key to step through just to make sure that it works, the connection string gets set, and then if I open the connection, it's open, close it down again, and everything works perfectly. Okay, so that's probably enough time talking about connection strings. I'm kind of starting to bore myself actually. So what I'm going to do is I'm going to delete the auto-generated connection string that I got from the wizard earlier on, remove that altogether. I'd still like to be able to switch between the different connection strings for Access and SQL later on in the code, just to demonstrate the differences, the certain differences between these two database types. So what I'd like to do is make a copy of these connection strings and store them as constants that are available to this module. What I'm going to do up at the top of the module, just above my subroutine and below option explicit, I'm going to say const. The first one I'm going to call constra access as a string, and I'm going to make that one equal to the connection string that I've created for Microsoft Access. So in fact what I'm going to do here is just copy this connection string and place that at the end of the constant declaration. There we go. On the next line I'm going to create another constant, const constra SQL as a string, and I'm going to make this one equal to, as you've guessed probably, the connection string for SQL. So I can copy and paste that one at the end. So there we go. So we've got these two connection strings now stored and available to the entire module. I just put a capital S in the name of that one. I missed that one there. I can now delete one of these two sets of lines which sets the connection string, and then delete the line which has the connection string for Access. What I want to do then is make sure that this line isn't commented out anymore. And when I want to set the connection string for this particular version of the subroutine, I can simply call on one of my two constants. I can say constra. I'll go for Access to begin with, and the next few bits of code we'll write will be talking to the Microsoft Access database. But now we've got a convenient way to switch between the two just by modifying a single line of code a bit later on. The next task is to open up a set of records from the database, load it into memory, and then make that available to be pasted into Excel. So to do that, we're going to declare a variable that's going to hold the set of records that we open up. So at the top of the subroutine, I'm going to say dim movies data as an ADODB.Recordset. So a Recordset class allows you to hold a complete set of records in memory, which means they're available to the rest of your subroutine. Just like with creating a new instance of a connection, we need to create a new instance of a record set. So down below, after we've created a new connection, I'm going to say set movies data equals new ADODB.Recordset. So that essentially creates, if you like to think about it as an empty box that we can fill up with a set of records. So that's the next stage. How do you actually populate a record set with records from the database? Populating a record set actually involves changing several properties of the record set object. So we're going to do that after we've opened up our connection. So let me just make a quick change to the way the code is laid out. I'm going to take away that blank line and give ourselves a few blank lines between opening and closing the connection. So obviously, hopefully for obvious reasons, you can only populate the record set while the connection to the database is actually open. Because we're going to be setting several properties of the record set, I'm going to use a with statement. So I'm going to say with movies data, spelling movies properly would help with movies data, and then a few blank lines, and we're going to put in an end with statement down at the end. Okay, so the first thing we're going to specify for our record set object is which connection it should use. So there's a property of a record set object called active connection. You might have lots and lots of different connections to different databases open in the same subroutine. So we need to specify which particular connection this record set will use. So we say active connection equals, then we need to simply pass in the name of our movies connection variable. So that successfully tells the record set which connection to which database to use. The next thing we can do is specify what the source of the record set is. The source of the record set actually specifies which precise set of records will be loaded into the record set. So this can be one of several different things. To begin with, we're going to stick to entering just table names into our record set source property. So if I just quickly switch back into Access and show you the names of the tables in our movies database, the one we're going to go for is called TBL Actor. These are exactly the same as the names for SQL Server as well. So if I go back to the SQL Server, just so you can see later on when we switch to the SQL Server version, the same table name TBL Actor is listed there as well. So back to the VB editor, the source for this record set in this case will be TBL Actor, entered as a string, and that will load all of the records and all of the columns from that table into that record set. Now there are a couple of slightly more complex properties of our record set that we also need to set. So after we've set the source, the next property that we're going to set is called the lock type. And we're going to make this equal to the option called AD-lock read-only. So you're always provided with an IntelliSense list which provides you with the list of valid options. So AD-lock read-only. Now that's fairly descriptive. It kind of says that we can only read the records, meaning we can't change any data that's in the record set that gets loaded. Now, of course, there are three other choices there with interesting sounding names, optimistic and pessimistic. If I just select AD-lock read-only, if you're interested in finding out a bit more about what the other options do, then the best thing to do is rely on good old Google. So if you Google for ADO record set lock type, and then it's probably the Microsoft Developer Network link that you're interested in, gives you the most technical description of the information. If I head to that page, this describes in horrific detail what each lock type does. Essentially, these control exactly when records get locked, when changes get made. As we're not going to try to modify any data in this particular example, we certainly want the read-only option. Apparently this is the default anyway, so if you don't specify this, it defaults to a read-only lock type. But I think it's always worthwhile being as explicit as possible when you're writing relatively complex code like this. So there's the lock type set. There's one more property to change. The final property that we're going to change is called the cursor type. And again, you get a list of valid options when you type in the equal sign. So we've got 4 choices here. Now again, probably the best way to find out the description of what these 4 choices mean is to rely on good old Google again. So if you search for cursor type rather than lock type, you'll again return a page for the Microsoft Developer Network, but you'll actually get a slightly better description if you use the W3 Schools option. So on the help page, it shows you a table that describes all of the various cursor types. Now, basically the cursor type describes or sets how dynamic our record set will be. Essentially, how often our record set will go back to the original database and check for changes that have been made since the record set has been opened. So this is important if you're going to open a record set perhaps when your workbook first opens up, and keep that record set open through the duration of the workbook being open. If you think about other users perhaps changing data in the database, you'll probably want to make sure that your cursor continues, or your record set keeps going back to check if things have changed. If you're going to do that, then the dynamic cursor type is the most sensible one to use. It detects all additions, changes and deletions by other users. Of course, that comes at some sort of expense in terms of performance. So if your cursor of your record set has to keep on going back to check the original data, then that's going to slow down the performance of your code. The opposite end of the spectrum then is the static record set. So that opens up essentially like a read-only copy of data into memory, and it will never go back to check if anything changes. There's actually even a slightly more efficient version of that, the AD Open Forward Only cursor, which is exactly the same as a static one, except that we can only move forwards through our record set. And as we're not going to be moving through our record set at all for this simple example, this is the one we're going to use. This is the most efficient one in terms of performance. So back to the VB editor, and now that we know that we're going to use the basic forward only cursor type, I can press Ctrl and space again and choose AD Open Forward Only. And that's all the properties of our record set defined. All we've got to do now is specify that we want to open up the record set and read some data from it. Now, opening and closing a record set is just as simple as opening and closing a connection. So after we've set all of its properties, we can simply say .open to open the record set and load the data into memory. And then further on down the subroutine, after we've finished with the record set, so I'm going to give myself a couple of blank lines, we can say moviesdata.close. And it's as simple as that. Make sure that you close a record set before you close the connection. So that's all the code that we need to actually open and close connection to the database and load a set of data. We should quickly give this one a quick test to make sure that all the things will actually work before we try to read data from it. So I'm going to use the F8 key to step through the subroutine. Just make sure that essentially you don't generate any runtime errors. And the most important lines, of course, as we saw, were when we tried to open the connection to the database, and now again when we try to open the record set itself. So that seems to have worked happily. Make sure that you do close those objects down again, and then we can work out how to get the data from the record set into cells on an Excel worksheet. Reading data from an ADO record set into cells on an Excel worksheet is actually really straightforward, because Excel VBA provides us with a native method that allows us to do that very easily. So we want to make sure that we create a new worksheet that will hold our new data. So I'm going to insert a worksheet into the worksheets collection. I'm going to say worksheets.add. I'm not particularly bothered about exactly where the worksheet goes, so I'm just going to use the add method without specifying any of its parameters. Then, after we've done that, I want to copy the data from our record set into cell, or starting at cell A2. So there's a reason I'm choosing range A2, which you'll see shortly in the video. So I'm going to say range A2 dot, and then there's a beautiful method called copy from record set. And this method is designed exactly for copying data from an ADO record set. So if I type in a space afterwards, you can see there's a single compulsory parameter called data as unknown. What it actually wants is the name of a record set object, so we can simply pass in our movies data record set. There are a couple of extra optional parameters there as well, macros and max columns, which I'll come back to shortly. But for now, all I would like to do is run this subroutine to make sure that it actually generates a new copy of a worksheet reading data from our Access database. So just to go back into Excel quickly, first of all, you can see that I've got 3 worksheets, which are pretty much empty. There's a bit of data on sheet 3. So we're going to insert a new worksheet which will end up to the left of sheet 1 with a copy of all the actors from our database. So if I switch back into the VB editor and simply run the subroutine, it'll run fairly quickly. Back to Excel, there's our list of data from the movies database. Now obviously there's a few slightly rubbish things about the data that's been generated. First of all, we don't get the column headings in row 1, so we need to sort that out. Secondly, the third column here, column C, is actually meant to be the birth date of our actors. The formatting of the birth dates hasn't been transferred, so all we've got is a raw underlying value of the date. We could just format that ourselves manually in Excel, but we'd like to make that happen in code, so we're going to add a bit of code that will do that as well. I guess one more small rubbish thing is that the column widths aren't set correctly, so we want to make sure perhaps that the column widths get set. And we can solve all of those things with a fairly simple bit of code that we can add to our subroutine later on. But before we do all that, I just want to make sure and reassure you that this code will work perfectly for a SQL Server database without changing much at all apart from the connection string. So if I go back to the VB editor again, and I'm going to replace our access connection string with a reference to our SQL connection string instead. So remove access and instead use our SQL connection string. And if I run this subroutine having changed just that single piece of information, what we ought to find is that, again, it runs fairly quickly. And if I switch back to Excel, I've got another worksheet with another set of data stored there. Slightly different data stored in the SQL Server version of the database compared to the Access version of the database. It's in a slightly different order, but the important thing is we've got all the same data, just by changing that single bit of information. The other really cool thing as well is that if you know the names of the other tables in your database, then you can change the data that you get access to just by changing the name of the table. So there's a table called TBL Director, and if I run that subroutine now, that will read all the director data from the movies database, or the SQL Server version of the movies database. And if I go back to the VB editor again and switch the connection string back to an access connection string, that will read all of the director data from the access version of the database into yet another new worksheet. Again, the order of the records is slightly different, and the actual information in our two different databases is somewhat different. The important thing is that we're connecting to completely different types of databases and opening up completely different tables just by editing a couple of simple strings of text. Now I'd like to make this subroutine a little bit better by adding in the column headings from the dataset that we open up. So to do that, first of all I'm going to go back into Excel and I'm going to delete all of the extra worksheets that we added in earlier on. So I'm going to select sheet 8 in my case, and then hold down the Shift key and click on sheet 5, and then right click and choose to delete all of them. Click delete just to tidy up a little bit. Now, back in the VB editor, we're going to write another little section of code that is going to loop over the fields collection of our movies data record set and list out the name of each field at the top of the new worksheet that we create. Looping over the fields collection of a record set is just like looping over any collection of objects in VBA. We'll need a variable which can hold a single instance of the type of object whose collection we're looping over. So I'm going to go to the top and I'm going to say dim movie or movies field as, what I'd really like to say here is adodb.field. But slightly oddly, you won't see the field keyword appear in the IntelliSense list. It used to in previous versions of the ADO object library, but it seems to have been deprecated. I'm not quite sure why. Anyway, I'm going to ignore the advice of the IntelliSense list. I'm just going to hit escape here, and you'll see that if I type in the word field with a lowercase f, if I click on the next line, it does still recognise that there is a definition for the field class. So we're kind of cheating a little bit here, using what could well be an unsupported class these days, but I'm going to use it anyway. I know that this will work for these examples. So there's our variable which will hold a single instance of a field object. What we can then do is, after we've added the new worksheet, we're going to write a little loop here before we take the data from the record set and place it into those columns on the spreadsheet. So after we've added the worksheet, we're going to say for each, and then I'm going to refer to the variable we've just declared, movies field, in movies data dot fields. So you'll see that the fields property is listed for a record set object, which returns a collection of field objects. Again, why the field class isn't listed in the IntelliSense anymore, I'm not entirely certain. But if we write this loop, and then we'll close the loop by saying next movies field, and we'll do this in a nice simple way. We know that when we insert a new worksheet, we have range A1 selected. So I'm simply going to say ActiveCell.value equals movies field dot name. So you see we get the complete IntelliSense for all the properties of a field object. So the name, of course, is the name of the column. Then we're simply going to say to move one column to the right. So we can say ActiveCell.offset 0,1.select. Once we finish looping, I'm also going to go back and make sure that we select range A1 again. So if we have a particularly large data set that has lots and lots of columns, we don't want to end up all the way at the right hand edge of the worksheet. So I'm going to say range A1.select just before we then copy the data from the record set, and there's our code written out. So if we test this one again this time, I'll stick with the access database and the director table. If I run it, have a quick look back into Excel now, we get a version of the record set with all the column names listed out, and the dates have been formatted correctly as well, as if by magic. If I just quickly switch back to the VB editor and do a couple of other things, let's change to a SQL connection string, and also change the name of the table we're using for the actor table rather than the director table, and then run it one more time, and just to prove that this will work again with a new set of records. I just realised that I've got a slightly different version of the actor table with an extra column in there which isn't populated for many of the actors. It's the date on which the actor died if they have died yet. So this is for a slightly different version of the database. There's not much data that's in there actually. Oh, there's one quick test version with a date of death. So there's a quick example of how you can loop over the collection of fields of a record set and list out their names to populate the column headings. One more change that it might be nice to make would be to make sure that all the column widths end up in the correct size once we've finished copying the data from the record set. So we can do that very, very simply by adding a single line. After we've finished copying from the record set, we can simply say something like range A1 dot current region dot entire column dot autofit. So that will apply the autofit method to the region of data that we've just pasted. So if I give this one more test, we'll stick with the same record set and the same data. Actually, I'm going to switch back to the Access database. Not that it really matters, just for this quick example. And then if I run the subroutine again, we'll find, if I switch back to Excel, we've got now a nicely widened column with the correct data neatly formatted and the column headings. I can't think of a much better subroutine than that. Just before we go any further in terms of talking about more complex things we can do with our record sets, I want to return to an idea I mentioned earlier on in the video, which is a way to make this subroutine work regardless of which version of ADO the user was running on their computer. So if you remember, we looked at the idea of the create object function and a technique called late binding. What I'm going to do is create a quick copy of this entire subroutine and paste it in just below the existing one. And I'm going to modify its name so that it's called copy data from database late binding. Now when you want to convert your subroutine into a late bound method, there's three main things you'll need to change. First of all, any reference to a specific class of object from a specific object library needs to be converted to the word object. So I'm going to start by doing that now. I'm going to change adodb.connection as object, adodb.recordset as object, and adodb.field as object. The second thing that you'll also need to change is the keyword new needs to be converted into a call to the create object function. So replace the keyword new there with a reference to create object, open some round brackets, and then the class of object you're trying to create must be converted into a string. So just wrap that up in a set of double quotes and close the parentheses, and we'll do the same thing for movies data. Change the word new to a call to the create object function. There is one more thing that we'll also need to change, which is a little bit less obvious. Anywhere where we have referenced any constants that belong to the ADO object library, so things like AD lock read only. You remember we saw this convenient list of options available to us when we set the lock type, and likewise for the cursor type. Now these constants are convenient keywords that actually represent numbers, and these keywords only mean something as long as we have a reference to the ADO library set. So one way to find out what the underlying values of these constants are is to use the F8 key to begin stepping through this subroutine. If I now hover the mouse over each of these constants, it will tell you what the underlying values is. So AD lock read only is equal to 1, and AD open forward only is equal to 0. So what we'll also need to do is convert these into their underlying numbers. So replace read only with the number 1 and forward only with the number 0. I think that's everything that we need to do to make this a late bound version of the subroutine. So if I just reset the subroutine at this point, what we can do is attempt to test it. And the only way we'll know that this works for sure is if we first of all remove a reference to the ADO object library. So let's remove that reference from Tools References and click OK. If I attempt to run the first subroutine now, it will fail immediately because it will not understand what an adodb.connection is. So I can click OK and reset the subroutine. If I try to run the late binding version, what we should find is that it works in exactly the same way as it did before, but now without relying on the fact that we have to have a reference to the ADO object library set. So you could send this subroutine, this project, to anybody with any version of ADO and it will still work. Now, as I mentioned earlier on, the disadvantage of using late binding is you have absolutely no link or no option to use the IntelliSense. If I try to refer to one of my variables like movies con and type in a full stop, I don't get any IntelliSense whatsoever. So for that reason, for the rest of the video, I'm going to revert back to using early binding. That means I'm going to remove this subroutine altogether. So let's get rid of that. And I'm going to go back and check the reference to the ADO object library. So Tools References, scroll through the list again to find Microsoft ActiveX, data objects and check the reference again to make sure that everything works. Okay, so now that we've cleared all that up, let's look at some more complex things we can do to set the source of our ADODB record sets. Now, before we start talking about more complex record sets, I want to stop and think a little bit about adding some error handling to this subroutine. Some of the things that we're going to do with our record set source are going to make the program fail when we try to open up the record set. I am going to do that deliberately, by the way. I'm not sort of just preempting my own silly mistakes. So because I'm trying to demonstrate some explicit runtime errors when we try to modify the source of our record set, we don't want to be left in a situation where our movie's connection is still open. So we're going to add a little bit of error handling code so that after we've opened up the connection, should anything go wrong after this point, then at least the connection will still be closed down. So we've covered error handling in a lot more detail in a previous video in the series. What I'm going to do is after the connection has been successfully opened, I'm going to add an on-error statement which says go to close connection. What I then need to do is create that label in my code. So I'm just going to copy that keyword, close connection, that I've just invented, scroll down to the bottom of the subroutine, and just above the line which actually does close the connection to the movie's database naturally, I'm going to paste in that keyword that I've just invented. Again, this isn't a built-in VBA keyword, by the way. This is just a label that I've invented. This could be anything at all, essentially. If I type in a colon after its name, then move to the next line, it will outdent itself to the left-hand edge. So after this point in my subroutine, if anything goes wrong at all, my subroutine will immediately jump to this label and then run any code through to the end of the subroutine. So that will successfully make sure that we always close down the movie's connection or the connection to the movie's database. We should also do something similar after we've opened up the movie's data record set. Why not? If we fail after opening up the record set anywhere between here and here, then the movie's data record set is left open as well. So what we can do is immediately after we've opened up the record set, we can write another on-error statement that says on-error go to, and then I'll create a new label called close record set. So again, I can copy that label and paste it in just above the line which does actually close the record set, type in the colon, and there it goes. So after this point in the subroutine, if anything goes wrong between here and here, then the subroutine will immediately jump down to this section and close down the connection. From this point in the subroutine onwards, if anything goes wrong, the subroutine will immediately jump to this label and it will run moviesdata.close and then moviesconnection.close. So this on-error statement makes sure that both the record set and the connection get closed. What we would ordinarily do as well is after we have finished with our custom error handler is we would switch the error handler back to normal error handling status, and we do that by saying on error go to 0. So that line simply resets the error handler. That will make sure that if we run through the program naturally, then after this line of code, everything else will happen according to normal error handling routines. It's not particularly important in this case because we're only trying to close down the record set and close down the connection, but just as it's good practice, I'm going to put that in there as well. So now that we should have a bit of a safety net when things go wrong, let's start trying to modify the source for our record set. Now, the really cool thing about the source property of a record set is that as well as just being able to pass in the name of a table, you can actually replace this with a complete SQL select statement. So essentially, you can write your query as a string of text directly into your VBA code. Now, I've made a complete series of videos on how to write SQL queries, which I'm not going to recommend you go away and watch the whole thing at this point, so I'm just going to cover a few of the basic things from that. What we'll do to start with is replace the call to the simple table name with a query that will essentially do exactly the same job. So instead of just saying TBL actor, what we would do is say select star or asterisk from TBL actor. I'm also going to add in a semicolon at the end of the table name. Now, in both Access and SQL Server, the semicolon is an optional character. It's essentially the statement terminator. It's completely optional, as I say, in both Access and SQL Server, but in other database engines, the semicolon is required. So I'll add it in here for the sake of completeness. Now if I run this subroutine, we'll end up with exactly the same set of results as though we had just used the name TBL actor. Just to quickly prove that, I'll run the subroutine and then have a quick look back in Excel, and there's a new sheet with the full list of records from the actor table. So obviously that's a bit more work to essentially get exactly the same results as just putting in the name of the table. But the beauty of writing the select statement is that there's much more power in what you can return. So for the next example, let's say that we only want to return a set of columns from the actor table rather than all of them. This means that we need to know a little bit about the names of the fields in that record set. So if I switch back to Excel, as we listed out the field names earlier, we can see what those are. So I only want to include the actor name, actor DOB, and actor gender fields in the next query. If I head back to the VB editor, to do that, we just need to replace the asterisk with a comma-separated list of the field names. Now, these aren't case-sensitive. SQL is a case-insensitive language, but I'm quite pedantic about matching case, so I'm going to make sure that the casing is exactly the same as it's listed on my worksheet. But as I say, this is completely unimportant. The whole thing could be written in all capital letters or all lowercase letters, and it genuinely won't make a difference. So, having done that, if I run the subroutine again, we ought to end up with yet another new worksheet, and this time it will have just the 3 columns that we specified. What I'd like to do next is sort the results of the query so that they come out in alphabetical order of the actor's name. So to do that, I can add an order by clause to the end of the select statement. So after the from TBL actor, but before the semicolon, I can say order by, 2 separate words, then the name of the field I want to order by, so I can say actor name. It's important to note that you don't need to have included this field in the select list, so I could sort by actor ID, even though it doesn't belong to the select list, because it does belong to the table in the from clause. So I'm going to order by actor name. That will actually sort it in ascending order automatically. You can optionally add the letters ASC to sort in ascending order, and DESC for descending order, obviously. I'm going to replace it with ASC, and then if I run the subroutine again, I'll end up with yet another output, but this time the actors' names are listed in alphabetical order. So hopefully you can see from this that it's fairly easy to write complete SQL queries directly into your VBA code as just a string of literal text. It's worthwhile mentioning that this works happily for Microsoft Access and also SQL Server. So if I change my connection string and run the subroutine again, once again we'll end up with another list of values from the SQL database rather than the Access one. So far everything works in identical ways, regardless of whether you're working with Access or SQL Server. Now, writing out your SQL select statements directly into your VBA code is a really powerful technique, but of course it does rely on you knowing quite a lot about how to write SQL in the first place. Which, of course, I suppose if you've already watched my video series on how to do that, you won't have any trouble with whatsoever. However, if you're more of a VBA developer than a SQL developer, then understanding select statements and how to write them can be a bit of a challenge. So I'm going to show you a quick way that you can get your select statements to be generated automatically, which we can then just copy directly into your VBA code. As we're looking at an Access database, we're going to use Microsoft Access to do this. So I'm going to switch back into my database for Microsoft Access, and what I'm going to do is I'm going to create a brand new query using the Create tab in the ribbon and choosing Query Design. When I do that, I can get to choose which tables I want to include in my query. I'm going to go for a fairly complex query this time. I'm going to involve more than one table. So I'm going to insert the director table and the film table, and then close that window down. I'm going to include a few fields from there, so I'm going to go for the director name, and let's have the film name, the film release date, and perhaps the film runtime in minutes as well. Then I think I'll sort my query by the director name as well. So I'm going to add a sort in ascending order of director name. And there's a query, which if I were to run it, I'd see a list of results that I want to get into my Excel spreadsheet. So if I go back to the design view, in Access, you can actually see the SQL that's been generated by your query designer by changing the view to the SQL view. So if you switch into this, you'll get a fairly horrible looking set of code. It's not laid out particularly neatly or formatted very well, but what you can rely on is that if you simply copy this entire set of text to the clipboard, head back to the VB editor and replace the current source. So what I'm going to do is remove everything there between my double quotes. I'm going to then simply paste in what I've just copied. That will mean as well, of course, that I've got to put all this onto a single line, making sure I've got correct spacing as well. Okay, so there's the complete select statement written out as a single line of text, including some join code, which is always a bit awkward to write out yourself anyway. If I then simply run this subroutine, what I'll see back in Excel is the results of that query. So directors and films sorted in ascending order of director name, and with the film release date and the film runtime minutes as well. So that's pretty neat as well. The fact that you can actually get access to write out your SQL code for you. Now you can use a very similar technique in SQL Server to get your SQL queries to be generated for you. So if I switch back into SQL Server Management Studio, making sure that I've got the movies database selected, I'm going to choose to create a new query. And all you get then is basically a blank page, and SQL expects you to write out your queries from scratch by hand. But we're not going to do that. We're going to cheat. We're going to right-click in the background of the query page and choose Design Query in Editor. And if I do that, it launches the Query Designer, which is very similar to Access's Query Designer. Let's generate a different query this time. I'm going to include the actor table, the cast table, and the film table. Then I can close down that window, and I get access to all three tables involved in the query. Let me just rearrange things a little bit, just to make things a little bit more clear. What I'm going to do is start checking boxes for the things I want to see. I'm going to include the film name, the actor name, and then a field called cast character name. So that shows me the name of the character that each actor played in each film. Again, you can see that the select statement is being generated for us automatically in the background. If I want to apply a sort, I can do that as well. I'm going to sort by film name, perhaps. So sort in ascending order of film name. And then that adds the order by clause. All I need to do now is select all this text. Once again, copy it to the clipboard, head back into VB, and then replace this version of the query with the new one that I've just copied. So again, in a set of double quotes, I can paste in the query that I've just copied. I'll need to do a little bit more tidying up than usual. So the query is written across several different lines. So I need to backspace off all the line breaks to make sure this comes out as a single query. I could also just, I suppose, concatenate the various different lines together, but I'm going to do it this way now that I've started. So eventually we'll get to the point where the entire query is written out as a single line, enclosed in one single set of double quotes. So the spacing doesn't actually matter, but I want to tidy up a little bit. So there we go, open double quotes there, and then right at the end of the line, close double quotes. So if I run this subroutine, I'm going to make sure that I'm going to use the SQL connection as well this time, rather than the Access connection. So make sure that I'm using the SQL connection string, and then run the subroutine one more time, and back in Excel, I've got the list of film names, the actors who played a role in them, and which character they actually played. So that's probably the most convenient way to get your SQL queries to be written out for you automatically. Of course, if you know SQL quite well already, you're welcome to write out your queries yourself by hand, but at least you've now got a choice for the different ways to do things. Now, unfortunately, you can't always rely on the query designers to return a valid SQL string that will work with an ADO connection, and that's especially true when you're using a connection to an Access database and you're trying to add criteria to your query using the where clause. So I've reverted to using the Access connection string here, and for the moment I'm just going to replace my entire select statement with a set of double quotes. So I'm going to paste in a new version of my query in just a moment into that section. I'm going to use the Query Designer in Access to generate a really simple query. So heading back to Access, I'm going to create a new query in Design View, and I'm going to include just a single table, the film table. Then I'm going to include a single field, the film name field, and then I'm going to add a simple criteria that will show me all the films whose name begins with the letter A. To do that, I'm simply going to add an expression to the criteria row of the film name column, and the expression is going to be A followed by an asterisk. So in Access, the asterisk is one of the wildcard characters, and it represents any number of any characters. Now when I hit enter here to enter the expression, it will be changed ever so slightly to add the word like, and then enclose A asterisk in a set of double quotes. So if I run the query, I'll get a list of films whose name begins with the letter A. And if I look at the SQL view, that will give me the SQL select statement that generates that set of results in Access. Now I'm going to copy this query just as I did last time, and I'm going to paste it into my VBA code inside that set of double quotes. And again, I'm going to have to tidy up by changing everything or getting rid of the line breaks so that everything fits onto a single line. But I've got a small problem with this at the moment. If I click away from this line, I'll generate a syntax error. And the reason for the syntax error is that I've got mismatched sets of double quote characters in my string. So just like we saw last time with the connection string, if I wanted to replace the double quotes, one thing I could do is essentially double up the double quotes. So I put double quotes, a asterisk, double quotes. That will solve the syntax error. Now that's one solution, but there's actually a better solution for SQL select statements. Rather than using double quotes to enclose text, SQL actually prefers single quotes. In SQL Server, in fact, you have to apply a special setting to the server to allow you to use double quotes to delimit text. Single quotes are the preferred way of doing things in SQL. So, having done that, we've got a valid, or at least no syntax errors, so we've got what looks like a valid select statement. However, if I run this subroutine and have a look back at the Excel spreadsheet, what I'm going to end up with is essentially a blank worksheet. It's got the film name column, clearly, so it's actually successfully executed a query. It just hasn't returned any results, and that's a little bit strange. Now the reason for all that is just in the same way that the double quotes are a Microsoft Access way of delimiting text, SQL prefers single quotes. The wildcard character that we've used, the asterisk, isn't actually the way to do things in SQL. Instead of an asterisk, the wildcard for SQL is actually a percentage symbol. So if I replace the asterisk with a percent and then run this subroutine again, when I look back at Excel again now, I will see a list of the films that I expect to get. So this is one of the slightly odd things about using ADO. Even if you're connecting to an Access database, you're not using exactly the same dialect of SQL to talk to Access when you're using ADO. In Access, if I try to replace the asterisk with a percentage symbol, and then look at the results of the query, I don't return anything. And that's the opposite is the case when you're using ADO. So in ADO, you must use a percentage symbol. In Access, you must use an asterisk. So that's a complication you're going to run into, something you must know, I suppose. You just have to know this and make sure that you handle this by writing out the correct wildcard characters in your queries. Now you also have to be quite careful when you try to apply criteria to date fields in your select statements. So I'm going to switch back to Access for the moment, and I'm going to add in the film release date field into my query. I'll remove the criteria from the film name field, and instead I'm going to ask to show films whose release date is greater than the 31st of the 12th, 1999. So essentially that's going to show us any films released from the 1st of January 2000. So when I enter that criterion, again a couple of changes get made for me, so I get hash marks enclosing the date in Access, and if I run the query, I'll get a long list of films whose release dates are all after the 1990s, so since the year 2000, and if I head to the SQL view, I'll get the query written out for me. And again, I'm just going to copy this query to the clipboard, head back to the VB editor, and then I'm going to paste in that query in place of the one that I've got currently. So I'm going to replace everything there with the new query that I've just copied. A quick bit of tidying up again, so take everything onto a single line, making sure there's spacing between the words that I need. And there's the basic query. Now, one thing you may have noticed as I was tidying up my select statement is that Access has automatically switched the positions of the day and the month in my date. So whereas I wrote out 31/12, 1999, day, month, year, because that's the correct way of doing things, that's how we do things in the UK, you can see that Access has actually converted it to US format. So by default, dates are treated in US format in SQL. And because the 31st can only possibly be the day of the month, Access converts it to month, day, year. Now, as you'll see, if I go back to Access, you can see that it's actually changed that in the SQL view of my query. But if I switch back to Design View, it's still shown in UK format, 31/12. Now, that's absolutely fine actually in this particular case. If I were to run this subroutine back in the VB editor, if I run it, I will end up with a list of films released after the date that I've specified. If I headed back to the VB editor again, and if I flipped around the day and the month to put it in the correct position, 31/12, then if I run the subroutine again, I'll get exactly the same list of films. So if I switch between these two worksheets that have been generated, you can see clearly that I've got the same list of results. Now that works absolutely perfectly because the 31st can only possibly be interpreted as the day of the month. It can't possibly be the month of the year. If, however, I was looking for a specific date, let's say I'm going to pick the 3rd of the 8th, 2007, so the 3rd of August 2007 as it's represented here. If I switch back to the VB editor, I'm going to modify my criteria so it searches for a film that was released on an exact date. So rather than greater than, it's going to be equal to, I'm going to try to enter this as 03/08 2007. Okay, so if I run this subroutine again now, then if I switch back to Excel, I'll see I essentially end up with a blank sheet. I get the column headings, but there are no films whose release date match the date I've tried to type in. And of course that's because, back in the VB editor, because the 3rd and the 8th could both be either the month or the day, SQL treats this as month, day, year. So March the 8th, not 3rd of August. So one thing to remember is if you're entering dates in SQL and you want to type these out yourself manually, then either remember that it's American format, US format, month, day, year, and if I run the subroutine again, I will actually return the result I'm looking for. Alternatively, what you can do is use a different format altogether. The international standard way of entering dates in computing. There is actually an international standard, would you believe, for entering dates in computing. So the way you do this in the ISO 8601 standard is you put the year first, then a dash, then the month, 08, then another dash, and then the day. So 2007, August 3rd. If I run this subroutine again one more time, we will see that we get the correct film. So we've got that twice, then there's the blank one, then there's the two original ones. So ISO 8601 is actually a sensible idea for entering dates. There's a nice Wikipedia entry actually about ISO 8601, which you're welcome to read about if you're interested. But otherwise, this is a nice reliable way of entering date information in queries in SQL. Now, dates in SQL Server work in almost exactly the same way as they do in Access, except for one very important difference. So I'm going to change my connection string to using the SQL connection string again, rather than the Access one. And I'm going to run this subroutine again from start. In fact, I'm going to use the F8 key to step through. This will make it easier to see what's going to happen. So if I use the F8 key to begin stepping through, I'll get to the point where I set my source for my record set, and there it goes. So that incorporates the date as we've just left it, so in ISO 8601 format, enclosed in a set of hash marks. If I carry on using the F8 key to step through, what you'll see that happens when I hit the open line is that instead of actually opening the record set, we jump to the close connection label. So that must mean that something has gone horribly wrong. We've generated a runtime error, and my error handler has made sure that we've jumped to the close connection label. So I'm going to run that. I'm going to make sure the connection does get closed using the F8 key, then end the subroutine. Now the problem with the dates as we've entered it, or the date that we've entered into our criterion, is that in SQL Server you do not use hash marks to enclose a date. Instead, you use the same operator that you use to enclose text, and that is a single quote. So if I change that so that my date is enclosed in a set of single quotes, and then if I run the subroutine one more time using the F8 key, just to show you that it will pass through and properly open the record set this time, so when I hit open this time, the record set does get opened, and then we add the new worksheet and add in all the data, and then the subroutine ends. So going back to the spreadsheet now, we'll see yet another worksheet which has the same film as we saw twice previously for the Access database, and then there's still the missing one. So this is the new query that's generated using SQL Server. So that's the one massively important difference with dates in SQL Server. Rather than using hash marks to enclose the dates, you use single quotes instead. As one final idea for this video, I want to talk about how you could actually get your users to influence the data source that's created. So we're going to ask the user to provide some input which will affect the number of records that we return from this query. To make this work, well, I'm going to show you first of all what the query itself would look like. So I'm going to go back into Access quickly, and I'm going to show you that I've got a basic query here with a film name, film release date, and film runtime minutes. And what I'd like to do is show a query, or show a set of results, where the film runtime minutes falls between two numbers. So the criteria that I can write to do that involves the between keyword. So I can say between, and let's just say, for example, 100 and 120. And I think I'm going to add an order by clause as well, sort the results so that you can clearly see the results come out in the range that I've specified. So, having done all that, if I run the query, you'll see that I get a list of results where the lowest film runtime is 100 and the highest is 120. But I might want to change that range of numbers each time I run the query. So I'd like the user to provide the values for the number 100 and the number 120. So I'm not going to copy this query just yet. What I'm going to do first is head back to the VB editor. And because generating this select statement is going to be a bit more complex, what I'm going to do is write a separate function that is going to return the correct result. So down at the bottom of this module, I'm going to create a new function called getSQLString. And it's not going to have any parameters, but it is going to return a string of text. So there's the definition of the function. Let's start writing the code that will actually return the right result. So I'm going to ask the user to provide two separate inputs for this function to return the correct SQL string. So I'm going to give myself a couple of variables, dim min length as integer, comma max length as integer. And then I'm going to ask the user to provide values for those by displaying input boxes. So I can say min length equals application.inputBox. I'm using application.inputBox rather than inputBox because with application.inputBox I can restrict the return type to a number. So I'm going to say call the prompt, or set the prompt parameter to say enter the shortest runtime, and then the type parameter. So if I type in a comma and say type colon equals, I can set this to a value that makes sure I can only return a number from the input box. If you want to see what value I have to enter here, I can click on the word input box and press F1 on the keyboard to launch the context-sensitive help page. And in Excel 2013, this actually goes into the default web browser to show you the results. But what you can see here is that if I want to return a number from this input box, I enter the value 1 for the type parameter. So heading back to the VB editor, I can say type equals 1, and that makes sure that I can only return a number or enter a number into that input box. I can do exactly the same thing for max length. So to save a bit of typing, I'm going to copy that line, paste it in, change my variable name to max length, and then change the word short to the word long, so enter the longest runtime, and the type will also be equal to 1. So now that will store the two values that my user has entered, I need to incorporate those into the select statement. I'm going to build my select statement in a string variable before I return the final result to the function. So at the top I'm going to declare another variable I'm going to call it SQL string as a string. And then a bit further down I can start building that up by saying things like SQL string equals. Now I could just copy and paste this from my Access query, but I feel like typing this one out by hand. So I'm going to say equals select film name, comma film release date, comma, I want to make sure I get the casing right, not that that's actually important, but I'm going to do it anyway, film runtime minutes, and then a space, and then I'm going to use an ampersand and a space underscore to carry on typing this line on the next line of code in the editor. So now I can just open up another set of double quotes and say from. It's important that I've got a space after the word film runtime minutes here, by the way, so there must be a space here, otherwise the word film runtime minutes would be attached to the word from, and that would cause an error when I try to open up the record set. So making sure you've got the spacing in the correct place. This is why it might be useful to copy and paste from the Access query. However, I'm going to persevere. I'm going to say from TBL film, and then make sure there's another space after the word TBL film before I close double quotes, and another ampersand space underscore, and then where film runtime minutes between. And this is the point at which I want to incorporate the first user input. So I'm going to use ampersand, and I'm going to say min length. Then another ampersand, space underscore, open up some more double quotes. I'm going to start this line with a space so that I get a space after the value that's been entered into the min length parameter. So I can say space and then another space, closable quotes, another ampersand. I'm going to join on the result of the max length variable. What I can then do is join on the order by clause at the end, so I'm going to say and space underscore, making sure there's a space after the max length value, and say order by film run time minutes, ASC, and close out with a semicolon. Phew, so when I hit enter now, as long as that entire section of code doesn't turn red, that looks pretty good. That will return then, oh sorry, it doesn't return yet. If I say then get SQL string equals SQL string, then that function will now return the correct statement that I can add to my subroutine. So all I have to do is head back up to the original subroutine and replace my source, take away that entire string of text, and replace that with a call to my get SQL string function. So, having done all of that, if I just save the subroutine or save the code that I've written so far, and then run the whole thing from scratch, I get to enter the shortest runtime. I have to enter a number. If I try to enter text and click OK, it won't work. I get a nice bit of validation. So let me replace that with the number. I'm going to go for the number 90 this time. Then I can click OK again. I'm going to enter the value 100 as the longest runtime. When I click OK, when I switch back into Excel, I ought to end up with a list of films whose running time is between 90 and 100. Fantastic. So if I go back to the VB editor and run it one more time, let's go for a slightly longer range this time. We'll go for 190. OK. And the value 200, perhaps. Click OK again, and now when I switch back to Excel, I get a list of the longest films. So hopefully that gives you a few ideas about how you can let the users now influence the result of your select statements. Really, the technique is just concatenating strings of text together, making sure that the user enters valid values that can be incorporated into your where clauses. Obviously, knowing a bit about SQL queries helps a lot, hence I'm going to mention once again the previous series of videos that we've created on writing SQL queries, but it's a nice way to get your users to generate unique sets of results from databases. So I think that's about as far as we're going to go with this particular video for getting data from a database. In the next part of this series, we're going to talk about how you can write similar code to actually start modifying the data that's in a database. So in terms of deleting records from tables and then updating existing records as well. So for the time being, hope you found this video useful, and thanks for watching. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.